Testing, Danny audio, test 1, 2. Chat, please let me know how loud I am. Testing 1, 2.
Testing 1, 2. Please let me know how I sound.
Okay.
Testing 1, 2.
And test with both of us together. Georgie, go ahead.
Yes, testing 1, 2.
Hello, everybody. How are you guys? I have my good extra special guest, Georgi Dinkov here. Georgie, how are you?
Fine. Thanks for restarting these.
Always a pleasure and fun to do, and you make them worthwhile, so thank you so much. Guys, if you were with us last time, you know that I had some battery problems with my computer, and so we're at like 79% battery, and so we're going to try to get through this show without my computer shutting off. And so I apologize for that. I think in Thailand, the AC current or something must just not be strong enough to power the computer, even though it's plugged in. So I will keep you updated on that, but we're going to try to fly through a lot of these articles basically as quickly as possible. And if you want to follow along with us, you can go to hateit.me. And Georgie, what article did you want to start with? We have vitamin D, the new antibiotic against skin and gut infections.
I mean, I have at least 20 posts since we last talked, but I think the first pages, all of them are pretty good. So that vitamin D thing is pretty important. Basically, it shows that vitamin D levels are crucial for the production of like a protein that's really important for immune system and specifically for battling bacterial infections. That protein name is, let me see, catalycidin antimicrobial peptide.
Oh, is that calcilycidin? Maybe I'm probably saying it wrong too. But yeah, that's the antibiotic in vitamin D, right?
Yeah, exactly. Catalycidin antimicrobial peptides. It's abbreviated as CAMP, which is actually not a good abbreviation because there's another enzyme which basically is also important for metabolism. It's also abbreviated as CAMP, but the C is not capital; it's lowercase. In any case, long story short, they basically show that levels of vitamin D are extremely important for protecting the mice from basically having their guts being overcrowded by bacteria, and potentially from preventing the initiation of inflammatory bowel disease. And the rates of inflammatory bowel disease, of diseases like Crohn's disease and ulcerative colitis, have been skyrocketing over the last 2 decades. And modern medicine continues to claim that it's unknown what the cause is. Even despite the fact that there's already a proposal that specifically Crohn's disease is due to a bacterial infection by a pathogen called Mycobacteria paratuberculosis. And there, in some countries like the United Kingdom and Germany, I think they actually have a antibiotic protocol similar to Lyme disease treatment. You basically go on this mixture of antibiotic treatment. Sometimes they give them intravenously, and you stay on it for a few months, which is pretty long. I mean, most antibiotic courses like 2 weeks, a month tops. But this antibiotic course for Crohn's disease is lasts much longer. Anyways, long story short, they showed that maintaining normal vitamin D levels made the mice extremely resistant to developing such infections in their gut. More importantly, they also showed that applying vitamin D topically on the skin at a dosage of about 60 IU per kilogram. That will be the human dose. This means about 6,000 units for somebody weighing about 200 pounds. I know it's pretty heavy, but it's easier to calculate. So dissolving the vitamin D in alcohol and propylene glycol, that solution was enough to actually completely sterilize the wound against a bacterium that is really resistant to antibiotics. So they were really surprised. I mean, they were able to treat the bacterial infection in the skin wound just by using this vitamin D solution. And before the people start saying that, oh, it's the ethanol, the propylene glycol that had this effect, it wasn't. They actually tested these separately, and it was the vitamin D that had this effect. And they think it's because of the increase of this CM peptide. So they basically say that vitamin D, maintaining normal vitamin D levels, is probably a very good approach to protecting from endogenous systemic bacterial infections, specifically the GI tract.
Mm-hmm.
And then if you have some external wounds, applying vitamin D solution to them is probably a great way to sterilize them and kill the bacteria and heal the wound. And on the plus side for vitamin D treatment, they thought that bacteria cannot develop resistance, unlike the bacterial resistance that can happen with regular antibiotics. It's another huge win for vitamin D, I think, and it just shows just how important vitamin D is for the immune system. And now, as you remember, we've already discussed in previous shows, the immune system factor is now recognized in cancer, in a number of different neurodegenerative diseases like Alzheimer's and Parkinson, also in diabetes and cardiovascular disease. And even though they're saying they don't know why, it's already been confirmed that the immune system is involved in these diseases. In other words, being suppressed. And when it gets suppressed, these diseases happen. Conversely, when you restore the immune system function, it has a protective effect against diseases that are not thought of currently as being of infectious origin.
I mean, don't you think getting the vitamin D up is one of the most straightforward ways to improve the health? Just getting that test, and there are lots of points of view on whether you should or shouldn't supplement, but I feel like it's almost a no-brainer. And I suspect that some people that have problem supplementing vitamin D, they might just be reacting to the actual supplement, and maybe they should try to put it on their skin, But I know there's a subset of people that think it's that will increase tissue calcification if you increase vitamin D, which I think is a little backwards. Like the vitamin D wouldn't increase the calcification; it's the parathyroid hormone.
Parathyroid hormone, yes,
yeah.
Exactly.
And so, but go ahead.
I was going to say, basically there was a number of studies in the 1940s which showed that serum cholesterol levels and vitamin D levels were basically they were almost perfectly. Vitamin D was almost perfectly correlated with level of thyroid function, and cholesterol was almost perfectly inversely correlated with thyroid function. So you can use these to test cholesterol and vitamin D as a great surrogate, because the regular thyroid test could be so unreliable, right? I mean, you can have normal TSH, normal quote unquote, based on the fake ranges that are currently published. But let's say you have a low TSH for some reason, you can still be hypothyroid, right? I mean, you can have high reverse T3, you can have low T3, and TSH could still be. If you take high dose T4, you will drive your TSH into the ground. That doesn't mean you resolve your thyroid issues, right?
Yeah.
And the way Broder Barnes dealt with this, Broder Barnes said, we'll measure your temperature, right, pulse, and the morning temperature, armpit temperature. But even those things, most people oh, that's so inconvenient, or maybe they mismeasure it, right? So another really good test was the Achilles tendon reflex, right?
Mm-hmm.
How quickly the tendon relaxes after being stimulated. That's a great test, but most people cannot do it themselves, and they have to go to a doctor for that. So if you want to rely on blood biomarkers for measuring thyroid function, the combination of cholesterol and vitamin D are probably two of the best you can come up with. In my opinion, they actually surpass TSH, because the only thing the TSH test shows is how stimulated or how suppressed your pituitary is. It really doesn't have that much relevance for your peripheral thyroid function, which is in the tissues, and how well they're utilizing the thyroid hormone, and basically how fast metabolism is, right? I mean, carbon dioxide is another great example. But anyways, long story short, vitamin D being a steroid, and because it is a downstream metabolite of cholesterol, just like the test for the gonadal steroids, testosterone in women and progesterone in men, vitamin D is yet another very good biomarker for thyroid function, for speed of metabolism. Let's call it speed of metabolism. And unlike the blood test for the gonadosteroids, the vitamin test is much more reliable, because for the gonado ones, you have to worry about tissue levels versus blood levels. They don't always correlate very well. They could depend on a number of different factors, right? But with vitamin D, the test is pretty reliable. So if your vitamin D is low and or your cholesterol levels are high, chances are your metabolism is not where it should be.
Yeah, it's surprising how many people still bet the farm on the TSH test, and I think that's just like a medical culture type of thing, because I've received like so many persons saying like, well, it can't be my thyroid because the TSH is so low. And then
Again, TSH is a pituitary hormone.
Yeah.
At the very best, it shows how well the pituitary is doing its job in producing it in response to low metabolism, and also how well the pituitary responds in terms of being suppressed. So you can actually use the TSH test for two things. One, you can basically use it to see if the pituitary will respond to a drop in metabolic function, which it should, right? And that's a good thing. If it doesn't, it's bad. I mean, actually, there are situations where TSH being low is actually bad, right? If your metabolism drops, TSH should jump, to compensate for this. It's basically it's called well-compensated hypothyroidism. The same thing happened with the gonadal function and LH and FSH pituitary enzymes. On the other hand, if you're taking T4 or T3 and TSH doesn't drop, that's actually a bad sign, right? I mean, basically means the pituitary, there's a tumor somewhere usually that's overproducing TSH. Usually in the pituitary, but not always. You can have some peripheral tumors that produce TSH as well. So that's really what the TSH test is good for. I mean, basically evaluating pituitary function and how well it responds, and the negative feedback mechanism, and if there is an issue with that, right? But it doesn't necessarily tell you much about the thyroid, right? It's a pituitary test. Then of course you can start measuring the T4 and T3, right? And that can give you some idea, because if your T4 is normal or high and T3 levels are not, then it kind of indicates the thyroid is doing its job, but your liver isn't, right? But it doesn't really give it a complete picture. It just gives you these piecemeal, these piecemeal puzzles about the pituitary, the thyroid, the liver, right? But somebody just wants to know, like, look, should I take thyroid or not? Am I healthy or not? Like that's really the ultimate question. And for that, to answer that question, usually the tests for cholesterol, carbon dioxide, and vitamin D are much better, because they depend on systemic metabolism. And if metabolism is not where it should be, cholesterol starts to rise for two reasons. Number one, because it doesn't get converted properly downstream, so there's some leftover, but it's not just the leftover. The body actually starts producing more cholesterol to compensate for the lower synthesis of the protective steroids. And then the vitamin D levels are low, and they're actually low in about 40% of the population, actually probably even higher in some cases. That tells you just how low metabolism is in a significant minority, if not even the majority of the population. And if you combine cholesterol, vitamin D, and carbon dioxide, I think it kind of gives you the outputs of metabolism, right? The input cholesterol, and then the output will be vitamin D and carbon dioxide. And if there's a dysregulation somewhere in the metabolism, if it's not working properly, you'll see it in one or more of these tests.
Yeah, Broda Barnes has a quote, and it's like a patient with a thermometer can figure out more than their doctor ever could, or something about their metabolism. Right. I don't know if I can find it real fast. Thermometer. Oh, I spelled it wrong. Okay, well, fuck it. Okay. Great stuff. And the one other thing I wanted to add in, I've known some severely hypothyroid people with really low TSH levels. And then Ray had a quote, and he pointed to a paper where he said that like a very hypothyroid situation could have very high adrenaline, and that could actually, depending on what phase of stress the person was in, could suppress the TSH. And so just wanted to throw that out there too. Okay. Thank you, everybody, for watching. I can't believe everything is working. I downloaded a new version of OBS. It's very early here in Bangkok. It's 9 a.m. Georgi, how you doing?
I'm all right. It's 9:20 here, 9:20 in the U.S. East Coast.
I wanted to plug Mr. Georgi's boutique supplement company, Idea Labs. So if you're interested in that, idealabsdc.com. And then you can also go to idealabsdc.com/lab for, what do you call them, Georgie? Research
The
chemicals?
lab chemicals, the research chemicals, yes.
You can follow Georgie on Twitter at HateIt, and he posts quite a bit on there, and so you should go check that out. You can follow...
Yeah, so the Twitter feed is basically a direct input. The Twitter feed gets all of its articles directly from the blog. So you can follow one or the other, but I guess the Twitter feed is easier to follow because it gives you a snippet.
But you're not a bot on there because we go back and forth, and so that's why you have some...
I'm not a bot, no.
Yeah.
No. I mean, I do answer people's questions there, but I'm saying if you see it, when it says like new article and being posted,
Yeah.
I don't post it there manually. Actually, the Twitter checks my blog periodically and basically gets any new article and extracts it and posts it there.
Awesome. I do coaching and email coaching as well, and I kind of renovated this page to be a little bit more clear. But if you go to dannyroddy.com/resources, you can find out about that, as well as I have like testing thyroid function, link to my book that I wrote in 2013, stuff about hair loss and other types of things. So I tried to make this page as useful as possible. You can follow me on Twitter at Danny Roddy, and I have an Instagram too where I try to post lots of food things. Okie doke. Let's get to the next article. I like this one, the vitamin E anabolic catotoxic steroids. Yeah,
it's perfect because it talks about soft tissue calcification,
yeah,
right?
Perfect.
And one of the authors of one of the studies is Hans Selye.
Yeah.
Which I think many people appreciate. So a couple of things in those studies, a couple of major things. First of all, they said that tissue calcification is actually both a surrogate for systemic aging and actually most likely a cause, right? And Ray spoke about this in several of his articles, that the ultimate self-death always results from overload of calcium. And it's really the intracellular calcification that causes a lot of these, like the stiffness and the crystallization that really occurs with aging. And as early as the 1940s and 1950s, people were agreeing with that and saying yes. So they had these animal models of accelerated aging, and they caused it by causing massive soft tissue calcification. And now people, the haters of vitamin D will do a victory lap with vitamin D. But guess what? The doses that they administered correspond to 500,000 units daily for humans. That's, yeah, sure. If you take that much vitamin D on a daily basis, you will probably have an issue, right? And actually, there's subsequent studies that show that even that can be prevented. And that's actually, we're going to talk about this vitamin E doing that and preventing it. But they show that you can actually prevent the calcification of even massive doses of vitamin D by co-administering with vitamin A. So it's really, even 500,000 units daily, it's not going to cause much damage if you know how to use it. But I'm hoping that nobody's using these massive doses of vitamin D. We're talking about 2,000, 3,000, 4,000, units daily at most. And at those levels, I don't think there is a published even case study which has shown hypercalcemia in the blood or soft tissue calcification. Anyways, long story short, these studies, of which Selye is one of the authors, demonstrated that pretty high doses of vitamin E, or basically the anabolic / catotoxic steroids such as testosterone, nandrolone. There's a steroid that Selye experimented with. He called it catotoxic steroid 1, CS-1. So a number of these catotoxic steroids were basically capable of preventing and in many cases reversing the soft tissue calcification, and as such, the process of aging. Because these studies made it pretty clear. Look, if we can reverse the symptom of progeria, which is early, abnormally early aging, then we could possibly reverse or at least learn a lot more about the process of aging than we know right now. And these were studies done in the 40s, 50s, and 60s. And then they also found out that egg yolk at the dose of about 100 grams daily, I don't know, that may be like 4 or 5 eggs, I haven't calculated it, but not the egg whites. Actually, the egg whites was one of the factors that increased soft tissue calcification. And the studies also talk about parathyroid hormone, estrogen, and serotonin as being the 3 primary endogenous agents that cause soft tissue calcification independently of vitamin D intoxication. There you have it. And they, in one of the studies, they actually said that testosterone and the other steroid they used, nandrolone, DECA, also known as the vitamin glucose, they actually worked by opposing the effects of estrogen and serotonin in tissues. And for vitamin D, they don't have an explanation how it worked. My suspicion is that, my explanation was that vitamin D is also an estrogen antagonist. That's probably its likely mechanism of action. But there are also studies showing that vitamin D lowers parathyroid hormone as well. So it could be a number of different explanations. Long story short, aging is likely associated or caused by systemic soft tissue calcification, driven by high estrogen, high parathyroid hormone, high estrogen. All of these are associated with hypothyroidism and also causes of it. They form a positive feedback cycle. And supplementing with protective steroids, vitamin E, or if you don't like any of these supplements, simply eating 4 to 5 egg yolks daily was capable of fully stopping this process and in many cases reversing.
Well, I always love that quote by Ray, and he says like calcification begins in the mitochondria, and he had some like path to that, and I think it was like swelling, so cells taking up water, then or like the inflammatory process and swelling basically being the same thing, and then the accumulation of intracellular calcium, and that leading to the fibrotic calcified state.
So ATP has an affinity for magnesium, and ADP has an affinity for calcium. So if metabolism is not working very well, the ADP to ATP ratio will rise. And as such, inside the cell will start drawing calcium in, right? And excluding magnesium. So you will end up with a cell that has a lot of calcium bound to ADP and just staying there, right? And the only thing that will get it out of there is if you restore the synthesis of ATP, because that's what draws magnesium inside of the cell, and it keeps it there too. So you cannot retain magnesium unless your ATP levels are at the appropriate level. I think that's why Ray always keeps saying magnesium. People keep asking about magnesium supplementation. He says, yes, you can supplement, but in order for you to retain it, it depends on thyroid function, it depends on metabolism, it depends on ATP.
Yeah, here's a paper from Fujita in 1991, and he says, aging as a background of diseases is also characterized by an increase in intracellular calcium. Diseases typically associated with aging include hypertension, arteriosclerosis, diabetes, and dementia. And he says, all cell death is characterized by an increase of intracellular calcium.
There you go.
Boom. Okay. Anything else? Oh, the one other thing I wanted to talk about, Chris Masterjohn wrote an article. It's called Vitamin D Toxicity Redefined, Vitamin K and the Molecular Mechanism. And I hope I'm not bastardizing this, but he was talking about how he thought like toxicity of like vitamin D was when a person got too much vitamin A and like a deficiency of, so they had like this delicate relationship. And if you did a huge dose, like you mentioned, that 500,000 units?
Unit daily.
Yeah, you just like disturb the balance of everything. And then of course, thyroid and vitamin A have a important relationship as well.
And vitamin K, right? So vitamin D's role is, it lowers the levels of parathyroid hormone, but vitamin D is actually responsible for the absorption of calcium from the intestine, from the diet, right? In the intestine. So all of this absorbed calcium, it can go only in 2 places, or actually 3. It can get excreted through the kidneys, it can get deposited in soft tissues, or it can go into the bone. And in order for it to go inside the bones, you need a protein called osteocalcin, for which the cofactor is vitamin K. So in order for you to produce amounts of osteocalcin, which takes that calcium and prevents it from being dumped into the soft tissues. And actually, one of the studies in that thread, if you look at it, it talked about it. It was a case report, a human study of reversing kidney calcification by giving that person 10 milligrams of vitamin K daily. So it's vitamin K that apparently that not only can take this extra calcium because of the higher vitamin D levels and basically dump it into the bones, but it can also stimulate the release of calcium from soft tissues and also put it into the bone. So whenever I take vitamin D, I always take some vitamin K with it. In my experience, I've never had a situation of like the symptoms of hypercalcemia, like your face twitching or your muscle twitching or cramps. whenever I take vitamin D with vitamin K. But if you take in the vitamin D even by itself, in doses of 5,000 units or less daily, like let's say 1,000 to 5,000, which is what Ray has been recommending as well. And the vitamin D calcium, I think at this point recommends 5,000 units daily too. I don't think there's a single published case study showing that demonstrating hypercalcemia in the blood or increased soft tissue calcification. You have to really abuse the vitamin D on a daily basis in order to get to that level.
Sweet. And one other thing, I know I'm quoting Ray a lot here, but somebody did write him about using a lot of vitamin D and the level not going up, and he recommended eating more liver. And I guess because there are so many different cofactors and the metabolism of vitamin D from the sunlight to cholesterol is like extremely complicated. And so I guess the liver had many cofactors for that process to happen. And then I know somebody who ate raw liver like every day and they thought they got a vitamin A poisoning, and they got lab tests, and their vitamin D, if I remember right, was like 126, but they weren't supplementing with vitamin D. And so I was like, oh, yeah, they were just eating liver. So I thought that was interesting.
Yeah, so also on the levels not rising, because I know he told some people that too, and I was able to confirm it in a few studies. They showed that in obese or severely overweight people, the higher doses are needed because the volume of distribution of vitamin D increases in a heavier person. You have more tissue, right? So the regular recommendations of like 2,000 to 3,000 units daily being sufficient, that's not true for a person, especially a person carrying extra fat, because the fat actually has like the uptake of vitamin D in fat tissue is inhibited for some reason. They don't know yet why. So basically, if you're carrying extra weight, and I think so you may want to do like double the recommended dosage for restoring vitamin D levels. If you go to the doctor and you have a vitamin D deficiency, most often they'll tell you go to the store and buy like the 1,000 units per pill product and take like one a day, right? And they'll be like very cautious, like don't take more because it's a problem, right? Well, if you're overweight, especially with carrying extra fat, I would actually take 2,000 to 3,000 units. That also happens to be the dosage Ray recommended. And even if that's not enough, I would actually try to take the 2,000 to 3,000 units daily orally, and then supplement with a little bit topically, especially over areas with extra fatty tissue, like especially the abdomen, chest, and back, because that's usually where the fat accumulates, or like thighs and hips for women. And that seems to help, because I had a few customers who did the same thing. They were basically using our vitamin D product both orally and topically, and it worked. And one of these people is I don't want to use the word morbidly obese, but they have a BMI of 36, and that worked. But when they were using it only topically or only orally, they weren't able to raise their levels, even though they were taking 5,000 to 8,000 units a day.
Wow. Okay, I won't stop after every article we do, but guys, click the like button. That really helps us out, and subscribe if you haven't subscribed already. Just a public service announcement. Okay, so I found out about this article that you had posted because I made a video about my side passion of deterring people away from the carnivore and keto diets, and you had linked this article that eating a pound of sugar daily has strikingly positive effects on male fertility. And while this isn't explicitly about libido, when I was doing zero carb, while I was like always focused on hair and things, but libido was just as much of a problem for me. And so I appreciate Ray's point of view and all the bioenergetic point of view in general, because I feel like it's helped me stabilize that problem. And if it ever is lower, I can have a assortment of things to do about it or to try. And there have been many times where eating carbohydrate seems to be very useful. So I know this is more in regards to fertility, but I just thought I'd mention that. So do you want to talk about this one?
Yeah, they actually. It's a pretty straightforward study. They fed these people like a regular diet, and then one group got an additional pound of sugar daily, and truly sugar, because it consisted of added sugar, which came from about 3.5 liters of fizzy drinks, or 550 grams, which is 1 pound of confectionery. So I'm guessing these people ate basically chocolate, candy, and or drank like 3.5 liters of Coke, which I think Ray mentioned once that when he had trouble finding ripe fruit in Mexico, he ended up drinking like I'm forgetting how many Cokes sweetened with sugar daily, but it was like a high number.
Well, I don't know if I've ever mentioned this, but like I might have. But in Mexico, one of the funniest things over living there for about 3 years was the little kids like walking home with litro Coke bottles,
Oh, yeah,
and
yeah,
that was something I saw so often, and it would never be like Crush or it would never be like Mountain Dew. It would always specifically be Mexican Coke, and then of course the adults did the same thing. And I remember asking like the Tiendo woman, like, "Do you think Coke is medicinal?" And she looked at me like I was nuts. but I swear to God, that was I mean that's another topic of the coca leaves and stuff. But I thought that was really interesting.
Yeah, and well, I don't know if not people know, but Coke and Pepsi are on the United Nations list of what is it? The list of most important medicines or something.
Oh, really? I didn't know that.
Because it's considered approved oral rehydration therapy. So I know they have these special products. I'm blanking on the name right now, but they sell them in CVS and Walgreens everywhere in the United States. So you can get like these electrolyte drinks, usually for babies. Pedialyte.
Yeah.
Yeah. But when you don't have Pedialyte, what do? And because the United Nations figured out that Coke and Pepsi have such high market penetration, you're likely to find them even in like jungle stores in the middle of Thailand. They said that if you're dehydrated, drinking a bottle of Coke or Pepsi is a pretty good way to restore cellular hydration.
Yeah, and just to point out, it's like Coke and Pepsi are useful partly because how bad the food supply is. Like those things are okay because if you're in an airport and you're flying and you haven't eaten for a while, like Coke might be the best thing available to consume. And that's
one of the easiest to digest and the safest, right? I mean, it's like you're not getting much other than caffeine, sugar, and a little bit of phosphoric acid, but it's really caffeine and sugar, which is what your body needs.
Exactly, but I think that's very hard for people to believe. But it's just again, it's not that Coke or whatever is necessarily like the most nutritious food in the world. It's that the food supply is so horrendous, I think.
Yeah.
Yeah.
Well, anyways, back to the study. 1/3 of the participants in the study had poor sperm motility at the beginning of the trial. So by the end, the quote is like, the authors were surprised to learn that the motility of sperm of all participants during the trial had become normal. And the study shows that sperm motility can be changed rapidly in a short period, and it seems to be closely coupled to diet. And of course, they're not trying not to emphasize the fact that not just diet, but the carbohydrate intake, because it's the increase, it's that additional pound of sugar that really made the difference. So if anybody's struggling with infertility, actually invariably, some of the people that email me and say, "Oh, we're struggling to get pregnant, to have a baby," and when I ask about their diet, at least one of them is more often than not, if not always, is on some kind of either low calorie, low carb diet, and or some kind of an exhaustive exercise regimen. And usually the people who actually manage to get pregnant, like they're saying, well, we're surprised, like we actually gained weight and we looked a lot unhealthier than we were before, but we were fertile. And I'm like, well, I mean, I'm guessing the criteria for healthiness has been really skewed over the last couple of decades. I mean, I get it; it looks better when you're a specific V shape as a man, or the hourglass shape as a woman. But this should be like in order for this to be healthy, this should be actually how you naturally look without going to the gym 6 days a week. Mm-hmm. If going to the gym 6 days a week is what is required in order for you to look that way, probably you're not healthy underneath. And as soon as you stop that regimen, things basically, you start piling on the weight. But ironically, biochemically, you're a healthier person because the body actually turns off the reproductive function first if things are not going well, right? It's the same thing as the brain. When you're under stress, the creative function, the higher cognitive function, those are the first things that get tossed to the side, and then you go back to your lizard brain, to use that term. So if that's what happens when you're under stress, when things are not going well, then conversely, if fertility is restored, chances are this suggests that you are in a better metabolic / systemic health, because otherwise the body wouldn't allow you to procreate because it's not considered, a crucial thing for immediate survival. So if that's what restored male fertility, I suspect actually, I think there was an older study. They didn't use a pound of sugar with women. I mean, the study was with women. They used honey. So they said basically drinking a shot of honey, which has about 28 to 30 grams, and most of it is sugar. So drinking 3 to 5 shots of honey, adding them to the diet, to the daily diet, restored fertility in women in advanced reproductive age, which is a code speak in medical circles for women in the age between 35 and 45. And above 40, sometimes they try to discourage women to even try having children naturally. They say, well, why don't you do like a surrogate mother or like adopt, because it's really not good for you. It's dangerous, right? Anyways, even in those women who couldn't get pregnant naturally, eating that honey restored fertility as well. So now you have 2 studies, one in women, one in males, showing that, and these people with 450 gram sugar extra, with a 1 pound sugar extra, many of them were actually overweight and obese. I forget the percentage, but I think it mimicked the general population percentage, which is 40 to 45%. So clearly, you can be overweight and at least reproductively healthy, but if you eat your sugar.
I'd like to point out that I think I consume, on average, about a cup of sugar a day. So I think I'm like this experiment for a long time. Okay, so anything else on this one?
I mean, it's just a simple study. That's pretty much all there is to it, unless you can think of something else. But yeah, I mean, it's just that's the only thing they tested: sperm motility and sperm count. So that was the result.
Did you want to talk about, in most cases, genes have less than 5% contribution to disease risk?
Yeah, that's.
I like that one. Yeah.
Yeah, but well, everybody knows about the Weissman doctrine, right? It basically says that you cannot pass traits that you acquire from the environment. You cannot pass them on to the next generation. And to this day, that's actually it's a dogma. It's a pretty established thing. You go to medical school, you learn about the Weissman doctrine. Even despite the fact that over the last 2 or 3 years, maybe 5, and we've discussed this on previous podcasts, there were studies that demonstrated that's not true, right? You can actually, the children of obese parents are more likely to be obese. Even if their grandparents weren't, right? The excuse always is, well, the gene if there is obesity gene, it may not get expressed in some generations, but it can get expressed in others, right? Mm-hmm. Yet no obesity gene has been found. There are also the studies that show that that mice that were exposed to like cat urine or a predator urine in their cages, like basically their offspring was also afraid of the cat urine without ever encountering a cat, right? So these things epigenetically can be passed. Medicine continues to basically deny the fact that significant non-genomic inheritance exists. And they're saying epigenetics is still a very nascent science. We don't know much about it, and let's stick to genes because that's what we know until we know more about epigenetics. Well, this study actually looked at what is the contribution of genes for most of the diseases that really matter to us, and they found out that for most people, the genes explain less than 5% of developing a particular disease, and for some cases, for some of the really bad conditions like cancers, diabetes, Alzheimer's disease, have a genetic contribution of 5 to 10% at best. And they also said that one of the key methods currently used by the genetics community, the gene-wide association studies, they kind of pour cold water on it and say these things are duds for disease prediction. So if less than 5% of your disease risk is due to genes, then the rest, like the vast majority, for most people, let's just say all of it, is due to environment. I mean, there's no other way to look at this. And if you read the interview with the authors of the study, they were pretty clear about it. They said, look, it's time that we take off our rosy glasses about the idea that genetics and gene editing will somehow resolve all of these issues, simply because things that you and I have discussed like for the last 4 or 5 years, 80 years of genomics research produced not a single gene proven to be causative for a specific one of these diseases, diabetes, Alzheimer's, cancers, right? And then not a single drug has come out that is even remotely useful. And now they're jumping onto CRISPR and editing genes, right? But so far, none of this has really materialized into anything useful for the general population. And these authors, who are themselves geneticists, they're saying enough is enough. Let's give the other, the other side of the room, the other half of the room, which screams metabolics. Let's give them a chance. I mean, we haven't produced anything. Maybe it's time to look at the environment and worry about it more. This reminds me actually of an article I read back in I think it was 2008. It may still be online. I'll send it to you. It was about Adderall and how Adderall has become the main tool for disciplining young unruly children in foster homes and in various institutions in the United States where basically problematic kids are being sent. And I remember the journalist was interviewing the head doctor at one of the facilities, and she was basically saying, so what is your method? And his response was, well, in this country, we have long ago given up on modifying the environment, so the only thing that remains is modifying the individual. And the only thing I can do when I get thrown 100 kids at me is feed them all this powerful drug, and basically that's how we control unruly children. But the thing that really stuck with me, and basically that I remember to this day, is that we have given up on the idea of modifying the environment because it costs too much, it's too hard, or we're not interested, right? So and this was a doctor who was like a Harvard graduate. So this must be, I know it's only one doctor, but I think he was speaking out of experience, that this must be the general attitude of the medical community as well, right? We cannot worry about the environment because it's too complex or too inconvenient to admit that we've created an environment that kills us. So we're gonna only worry about you. But again, if you're only worrying about the individual and how the individual reacts to his or her environment, that's patchwork, right? I mean, you can invent 1,000 different drugs, and at the end of the day, it still would come down to modifying the environment because I forget, it was I think it was Linus Pauling who said that being well adapted to a profoundly sick society, sick world, is no measure of health.
That's really weird. It was Maslow, but I'm actually looking up a Maslow quote as you said that.
Well, synchronicity again strikes again.
Well, let me just go ahead and read it. So the reason why I was looking it up is there's discussion of what is and isn't healthy in the chat, and so this was always something that was fascinating to me for many reasons. But I know I've told this story 100,000 times, but I knew people in the ballet company that had the most chiseled physiques I've literally ever seen. They were statues of such amazing physiques. But when I would get to know some of these people, it was clear that there were serious issues with them.
Yeah.
And so again, living in San Francisco is really a time that shaped my point of view of what was healthy and what wasn't. And also, I don't think it can be undercounted that the environment is so bad that it just seems like maintaining a level of health in this environment is fairly difficult at all, And so, for example, I'm in a condo right now, and there's probably 100,000 Wi-Fi routers here, 5G Wi-Fi routers, And so I'm probably being harmed just sitting here. So I brought up a quote, though, and it's from Maslow, and he says, "I am deliberately rejecting our present easy distinction between sickness and health, at least as far as surface symptoms are concerned. Does sickness mean having symptoms? I maintain now that sickness might consist of not having symptoms when you should. Does health mean being symptom-free? I deny it." And he goes, "Which of the Nazis at Auschwitz or Dachau were healthy? Those with a stricken conscience or those with a nice, clear, happy conscience? Was it possible for a profoundly human person not to feel conflict, suffering, depression, rage, etc.?" He goes on there, and it's really good. I encourage anybody to look it up. I forget what book it's in, but again, it's something I admire about Ray Peat is I think he exudes kind of health in his interactions, and so that might not be the most obvious thing to a person, but I think being a non-authoritarian asshole, not being that, is a sign of health. And I know few there are like that's very common in the health world. Like people want to control other people. People want to tell people what to do. If you don't do it exactly as they say, you know, there's some malfunction with you. And so I think I see ill health in the health world all the time. And so I think judging like aesthetics, especially when you don't hang out with that person. Like if I'm sure if you hung out with some of the health guru people on the internet, like you might notice dysfunction when they're waiting in line at the grocery store and they get upset over something really trivial or something like that. I don't know. But yeah, I don't know.
I've had experience with these people too. I mean, when I was still going to the gym on a daily basis back in 2008, before I had my run-in with health issues, the two personal trainers that were there, I know them because one of them is now a client. One of them turned out to have hepatic steatosis, and that person was the spitting image of, at least externally, of health. I mean, he had like a body fat of under 6%, which is like what competitive bodybuilders have. And he was, pretty bulky, muscular person, right? No, but of course, it turned out that this is due to heavy use of steroids, at least in his case. And then another person who was running the Soul Cycle class. I mean, if you look at her, all the women were like salivating all over her body because she was just this skinny, fit person who when I first saw her, my evaluation, like when I first see like females in terms of health, is like the subconscious, like, are you attracted, right? I mean, I know it could be very subjective, but I wasn't, and she had a very androgynous kind of look. There was no difference between waist and hips, but she was really like wired and muscular, and she had like the perfect biomarkers. Her doctor told her, "Oh, your cholesterol is really low, excellent, right?" And then basically, like within 2 years, she developed breast cancer. And another thing that I noticed is that like before, she had pictures of like before and after, before she started doing Soul Cycle and after. And before the Soul Cycle, she actually had very well developed breasts. But after embarking on this program, and she paid $10,000 to one of the gurus, who happens to be from San Francisco, by the way, to get trained as a trainer in Soul Cycle. And basically, like shortly after she got diagnosed with breast cancer, he got diagnosed with liver cancer. I don't know if it's steroid use or something else, but invariably, like a lot of these people that at least I run into, that looked like a spitting image of health, and everybody was admiring them and being envious of their physique, turn out to have some really serious systemic underlying health issues. And again, I mean, it goes back to the thing that we keep bringing up every single time. It's like if you have to, in order for you to look healthy, or at least what we've defined as healthy, if that means spending 6 or 7 days out of the week in the gym and running your butt off, or like lifting weights like a madman and watching every calorie you eat, then it means this is not healthy. You're putting in way too much effort and attention into something that to a healthy person should come more or less naturally, right? I mean, it's perfectly normal to avoid eating cake with every meal. I mean, that's something that, it's common sense. We don't even need to measure it. But you have to count every calorie. And if even a grain of rice would like make a difference in your book, then I would argue that things are not going in the right direction, even if you look like they're going in the right direction. Sooner or later, something comes up that demonstrates that this attitude of controlling life fully, right, to the point of everything being an exact science, it just doesn't work that way. I mean, life is smarter than us in so many respects, and this is one of them. Like if you're trying to develop perfection in an imperfect world, then you pay the price.
Well said. Guys, if you could please like this episode, that would be really support Georgie and I. So thank you for doing that, and subscribe if you haven't already. I am sitting at 48% battery. So this is really terrible.
Oh,
and
wow.
I need to figure this out somehow, but I think it's just the Thai power outage. If people are joining us now, my battery is like going down slowly as we have this conversation. My screen is like practically black. I can barely see the screen, so I had to turn down the brightness a lot to hopefully save battery. IdeaLabsDC.com, Georgie's boutique supplement company. Go check it out. And if you checked out the last episode, he's actually doing studies on his supplement. So Cortinon, a progesterone to DHEA supplement for cancer and things. Very interesting. And we'll keep you guys updated on any news that comes out of that. You can follow.
And a study with DHT and prostate cancer, which I think every endocrinologist in this world should be interested about, because so far the results are staggering. I don't want to jinx it. Let's see what comes out of it. But if I can get that published, if I can convince our journal to commit suicide and publish this, I think we're going to have a very interesting 2020.
You can follow Georgi on Twitter at HateIt. I do coaching, and you can go to DannyRowdy.com/resources. And in addition to coaching, you can actually see various like testing thyroid function questions I get asked like all the time, like useful lab tests I think are useful. You can follow me on Twitter. Oh, this was, I brought up something about when we were talking about genes, and I might as well mention it, but this was T.D. Lysenko quote, and he said, heredity is the effect of the concentration of the action of external conditions assimilated by the organism in a series of preceding generations. And then maybe a simpler version of that quote is by somebody named Luther Burbank, and they said, heredity is the sum of all past environments. And the reason why...
Isn't that obvious? That's what Lamarck said, right?
Yeah.
I mean, this is like, it's been going on for ages, and nobody talks about this in medical schools.
But I think when I suspect that when people hear us say that genes don't have a big impact on the outcome, that we're denying hereditary.
That's precisely why I preempted this by saying that just because something is hereditary doesn't mean it's genetic. That's really the thing that throws most people off. Because I've talked to psychiatrists and they're saying, oh, it's quite obvious 70% of depression is genetic. I mean, it runs in the family. So I'm like, have you ever considered that it could be heritable without genes? No, impossible. Why not? Weissman doctrine. Dude, look it up. Like, what do you mean Weissman doctrine? We know at this point it's you can inherit things that through a non-genetic pathway. Well, again, the response from smart people is, it's just one study. Let's give it some time and see what comes out of it. While others saying, I don't want to discuss this. I work in genetics. It's either this or I'm unemployed or homeless or worse. So we've gotten, unfortunately, to the point where I suspect that quite a few of the geneticists and other people working in the field are actually are already reaching the point of they're saying like, look, something is not right with our field, but I can't switch jobs now, right? I've dedicated 20, 30, 40 years of my life to genes. What am I going to do with myself if tomorrow it turns out that genes are useless when it comes to disease? I mean, not useless, but there may be 10 or 15 diseases at this point that are really known to have a genetic component. And this is not nearly enough diseases to justify the 500,000 or so geneticists around the world, maybe even more. So they're not dumb. Like even as authoritative as they are, I mean, I know people who work in genetics at NIH, and they're always worried about their jobs. They're saying like a few of them got fired recently from pharmaceutical companies working on drugs that silence or enable certain genes or activate them. And they're worried. They're saying like the market seems to be drying up. Even though it seems everything's going well for the genetics field, or computational genetics is now a really huge thing. There's a lot of federal government investment in it. In terms of if you're a geneticist and you want to work in medicine, then most of the people that I know are very afraid right now. I mean, they're trying to switch to computational genetics or bioinformatics or doing something with computers because the money is there. If you're a geneticist and you want to work for a company that will produce drugs that are focused on genes, tough luck. And like many of these people are unemployed, and the ones that are very afraid for their jobs.
And just to piggyback on that, Cold War in Biology by Carl C. Lindgren is like a must read for anybody interested in the prevailing gene theory over the vitalists or the animists or whatever you want to call them.
The Lamarckians. I like the Lamarckians. Yeah. Okay,
let's do the redox, the NAD to NADH, then get to super chats, and I have 44% battery, and I think we'll have enough time for that. Okay. But you got the file I sent you?
I have it in my email. Should I open it up?
I mean, it's just the post you did. So I wanted to talk about this because I made last week I made a video about carnivore or low carb or whatever, and I think the proponents of the low carb diet, they hear cortisol and they kind of have a knee jerk reaction, and they say they will construct some argument or whatever to say, well, cortisol doesn't increase on a ketogenic or low carb diet. So that point has been just debated to death. So if I set that aside, I think the bigger point is that when you fast, when you go on a low carb diet, or if you have just an excess of free fatty acids and your glucose oxidation is inhibited, so you're just stressed in general, no matter what type of diet you're eating, I think the most coherent way for the big picture is to talk about the NAD to NADH ratio. And so I think that's, and you have a post, the one metabolic cause to rule them all. And I think that was really apt. And so I wanted to go through this because again, it's not like, it's like, oh, Ray Pete says that eating low carb will stress you out. But I think it's much more interesting and elaborate. And so I think, and you can also weed through the fine details when you talk about the NAD to NADH ratio.
So you want me to go over the cycle? Or basically how it works?
Okay, well, the oxidation, loss of electrons, the reduction, gain of electrons. But yeah, if just your elevator pitch for NAD to NADH, glycolysis, pyruvate dehydrogenase, or the link reaction to Krebs to electron transport chain, cytochrome C oxidase, cardiolipin, all that thing forming oxidative metabolism, and that reinforcing our structure. Basically, Ray's hypothesis, but in a more granular way.
Yeah, so basically, when you're eating carbohydrates, they'll have to go through the glycolysis step first, right? I think it's got like 8 sub-steps or something like that. But the output of the glycolysis is this molecule called pyruvate, right? Glucose gets metabolized into pyruvate, and a buildup of NADH, which is the reduced form of NAD. And that's really how we produce energy from food. We carry electrons, not carry, but like, so the way we think of us as a light bulb in between the 2 poles of a battery, and then one pole is supplying electricity, which is food, right, in the form of electrons. In the case of biology, it's ions, the hydrogen ions. And these hydrogen ions get passed along a number of different steps, and eventually they meet with oxygen, and the output product is water. And in some of the other steps, another output product is carbon dioxide. Now, if there are a number of different, across all of these steps, there can be an interference with the passage of this hydrogen ion from one step to the next. But some of these steps are more crucial than others. It's rare to have inhibition in the steps of glycolysis. And usually if something like this happens, these are really severe diseases, and most of the children that are born with some kind of a genetic inborn error in one of the substeps of glycolysis, they don't tend to live very long. They tend to die very early, probably even before birth. They may even be stillborn. So let's say glucose makes it through glycolysis, and the output is pyruvate and NADH. So then, and this happens in the cytosol of the cell, right? So the next step is to get into the mitochondria, which is where oxidative phosphorylation goes. So glycolysis proceeds without the need of oxygen. It can be done anaerobically. So in order for you to consume oxygen, you need mitochondrial metabolism, which is where the next 2 large subsections of metabolism, which is Krebs cycle and electron transport chain, that's where they are located, inside the mitochondria. So in order for the pyruvate to enter the mitochondria and in order for it to start feeding towards the end goal, which is oxygen, pyruvate needs to be converted to something called acetyl coenzyme A, right? And in order for that to happen, there's an enzyme called pyruvate dehydrogenase, which takes as an input, takes pyruvate, and it has a cofactor. I think the two cofactors are magnesium, thiamine, which is vitamin B1, and also NAD, right? So what happens if you have a buildup of pyruvate and buildup of NADH, and the enzyme pyruvate dehydrogenase, PDH, is not working? Well, in order for the body to stay alive, it needs the oxidized version of NADH known as NAD. So how can it get it back, right? This NAD was used during the glycolysis to generate NADH, to accept these electrons from food and carry them towards the next step. So now you have pyruvate as an intermediate product and NADH. If PDH is not working, pyruvate dehydrogenase, then the buildup of these two molecules is the only thing that the body has. Remember, oxygen is not available. You cannot use oxygen to oxidize NADH while it's still in the cytosol. So what would be the emergency oxidant in this case? Assuming you're not taking anything, any supplements, but we'll get to the supplements and how you can help this issue later, right? So in the absence of any external help, the only thing available to the body to use is pyruvate itself can be an oxidizing agent. Now, not many people know, but pyruvate is actually the keto acid of the amino acid beta alanine. And the reason I'm mentioning this is keto acid is to bring up the point that ketones, keto acids and ketones can serve an oxidizing function, which is may explain why ingesting externally ketones may help with certain metabolic problems, but we'll get to that point later. So pyruvate could be an oxidizing agent. So the enzyme lactate dehydrogenase, which is inside the cell, if there is a buildup of pyruvate and if there is a buildup of NADH, the enzyme LDH, lactate dehydrogenase, will take the pyruvate, will take the NADH, and use the pyruvate and say oxidize NADH back into NAD. But in the process, the pyruvate gets converted to lactate, right? So then what happens with this lactate? The cell really does not like lactate. It does everything possible to get rid of it and immediately pumps it out into intercellular space. So two things. When the lactate starts building up, first of all, you're already in a hypoxic environment because when lactic acid builds up, your tissues cannot properly extract oxygen from the blood and get oxygenized. So this lactic acid, when it builds up, the only thing it can do is it can get shuttled to the liver and then get converted back to glucose inside the liver through a process called the Cori cycle, right? But here's the thing. If the PDH enzyme is not working, okay, the liver converted the lactic acid back to glucose, so you're kind of okay, right? If the liver is working well. If it's not, then you're kind of screwed. Lactic acidosis is actually has a 20 to 30% mortality rate. And now they're finding out that many of the patients with diabetic ketoacidosis, which coincides with lactic acidosis, and it has such a high mortality rate, even in hospitals, they're actually dying because of their high lactic acid, not because of their high keto acids that are resulting from the metabolism of all of this fat. It's really the lactic acid that kills them. So the liver converted this extra lactic acid back to glucose, right? But you're back at step one. So this glucose has to go through glycolysis, right? Generate NADH again and pyruvate, and you're back at the rate-limiting step of metabolism of glucose is pyruvate dehydrogenase. So the things that determine the function, the primary factors that determine the function of this enzyme is the availability of vitamin B1, the availability of magnesium, and actually, ironically, the ratio of NAD to the NADH. But it's the mitochondrial ratio of NAD to the NADH. And in order for this ratio to be high inside of the mitochondria, this means that the Krebs cycle and the electron transport chain have to be working well in order for this intermitochondrial NADH to be reoxidized back into NAD, because inside the mitochondria, the cell doesn't have the emergency option of using pyruvate or another like a emergency oxidant, unless, again, I'm giving the disclaimer, unless you're supplementing with something. Like quinones, right? Things that like emergency oxidizing agents. So if the pyruvate dehydrogenase enzyme is working well, then basically it takes that pyruvate, right? And it converts it into acetyl-CoA, right? And then you have the Krebs cycle, which I think has like a 6 or 10 different substeps. There are several substeps, and then they create additional intermediaries. So the acetyl-CoA can basically get converted into alpha ketoglutarate, succinic acid, fumaric acid, and ultimately towards there's no end because it's a cycle, right? But the last one of there's a step in the Krebs cycle from which the succinic acid can actually jump into the electron transport chain, and the first step is known as succinic dehydrogenase. That is the enzyme that is the first one of the electron transport chain. And along all of these steps, you're basically oxidizing NADH, accepting that electron, reoxidizing the NADH back into NAD, and also generating carbon dioxide. So most of the carbon dioxide that is a result of the metabolism is generated inside of the Krebs cycle, which is part of the mitochondria. So once you reach the electron transport chain, you can have a number of different reasons. There are four levels, electron transport, four complexes, electron transport chain 1, 2, 3, and 4. And each one of these could malfunction for a different reason. Like, for example, succinic dehydrogenase, the cofactor for that is NAD. So you don't have NAD. If the NAD to the NADH ratio is low, in other words, if you have a buildup of NADH, succinic dehydrogenase will not work well. Then the second electron transport chain complex 2 is dependent on coenzyme Q10, but it's also this quinone. Actually, it's a redox agent, right? So it can be in an oxidized and a reduced state. Ubiquinone is the oxidized state of the coenzyme Q10, and basically after it accepts an electron from NADH, it gets reduced to something called ubiquinone. So in order for it to get recycled back into the oxidized state to keep that step running, right? This ubiquinone also has to be oxidized back into ubiquinone, which also depends on oxygen, right? It also depends on the NAD to the NADH ratio. And then step 3 and step 4, step 3 is the cytochrome C reductase, and step 4 is cytochrome C oxidase. That last step is really crucial because that enzyme cytochrome C oxidase can get damaged very easily, can get blocked from activity by a number of different external and internal factors. For example, nitric oxide can form a really strong complex with cytochrome C oxidase, and in that state, the enzyme is not functional. So you can get stuck at that step, and it's that last step that basically binds that hydrogen ion with oxygen to form water. So you can have all of these steps working until you reach step 4, and basically at that step, if it's tightly bound to nitric oxide, your oxidative phosphorylation is not working properly. And so that's why buildup of nitric oxide is really pernicious, because it has such a systemic effect on oxidative phosphorylation, even aside from its role of being a pro-inflammatory agent.
And Ray quotes a paper by a guy named Bricks, or it might have been another paper, but that's the. Would you agree that the shift towards the NADH over the NAD is like a state of pseudo hypoxia? And so if somebody, it's going to be obviously more extreme during starvation. If somebody goes on a ketogenic or low carb carnivore diet or whatever, my friend Andrew Kim, he used to say it was like living on the edge of subsistence. And of course, you're lowering the metabolic rate to meet your energy producing ability. But I that pseudo hypoxia seems like a good encapsulation. What do you think?
Yeah, I mean, if nitric oxide is high, you cannot properly use oxygen. So you can be perfectly well oxidized in terms of, like, for example, this pulsimeter and oxygen saturation device that many hospitals use, right? Mm-hmm. Well, it can tell you, I guess the only time it's useful if the number is like really low, mm-hmm. or it stays abnormally high, even when the person is obviously not healthy, right? So, like as Ray said in one of his articles, a corpse, if you give this to a person who recently died, if you measure their oxygen saturation rate, it's going to measure at 100, right? Because there's no metabolic activity in their tissues to use that oxygen that is already in the blood. So if you measure their oxygen saturation rate, of course it's going to be 100, because that oxygen that is still in their blood is not getting used. Over time, it will decline because of the buildup of anaerobic bacteria in the body and when the decomposition starts. But initially, like a recently dead person will have 100% oxygen saturation rate. So that doesn't tell you much. It tells you just how much oxygen is present in the blood, right? So you can detect things such as lack of hemoglobin, right? There's a condition called methemoglobinemia, which is treatable incidentally with methylene blue and a number of different quinones. So that condition can get probably very easily detected, or at least a suspicion of this condition can arise if your oxygen saturation rate drops, let's say, below 9. But at the same time, oxygen saturation rate between 90 and 95 is usually where you expect this is a reading that you expect to get if your metabolism is actually fairly good, because if you're producing enough carbon dioxide due to high metabolism, basically the oxygen in your blood should have very high rate of dissociation from the hemoglobin and entering the tissues. So if the metabolism is sufficiently high, like the rate of breathing is basically slightly behind the rate of utilization of this oxygen from the blood and going into the tissues. So you could have an oxygen saturation rate on this device that measures it that's below 95. And if you talk to any doctor, they'll tell you, oh no, 95. If you're below 95, you're having problems. Something's wrong with your lungs, or you like something wrong with your blood. You just can't properly carry oxygen, right? But it turns out that's not true. Actually, the healthiest people have a reading between 90 and 95. Actually, between 92 and 95. It starts dropping below 92. I mean, it's probably an indication of something not very good happening, because that it's just not that many people whose metabolism is that good. I think Ray mentioned once that when he took a very high dosage of thyroid, and he did a reading, and it was like at 87 or something, or 88,
Mm-hmm.
and his one of his friends was a doctor and freaked out, told him to go to a hospital, and then within a few minutes, no, I'm sure, I think in a few hours, because I think Ray took T3. In a few hours, it climbed back to like 92 or 93, and he explained it to the doctor, and the doctor was shocked because he actually had never learned of the Bohr effect in medical school, or at least he didn't remember it. He didn't think it was something important. Would you let me turn on the light, because completely invisible now?
Yeah, go for it. Yeah. Okay, guys, thank you so much for joining us on a Saturday. Apologies for moving this episode. We just had a schedule conflict, and so we don't normally do that, but just happy to make it happen. Please like this episode if you guys haven't already. That really helps out and supports us. We're doing the giveaway. We've been doing that ever since we started this, and the winner this month was Lisa Biskup. And so thanks for entering, Lisa. And you need to email me, Danny@DannyRoddy.com, and then give me your address, and then I'll forward that to Georgi, and he'll send you out a bottle of Tocovit Vitamin E. So thanks for that. And to enter the giveaway, all you need to do is like the episode, leave a comment, and subscribe to the channel. And thanks so much for that. So I have 33% battery. I'm not positive my computer's going to turn off when it gets down super low. It might keep it up, but we really don't want to take that chance.
I'll hurry up. So bottom line is, so when you're in a reduced state, right? I mean, it's really affecting several core components of your metabolism. Above all, pyruvate dehydrogenase, which happens to be the rate-limiting step of glucose metabolism, right? And then there could be other factors such as high nitric oxide, which happens to rise, not only as a result of inflammation or infection, which is its primary purpose, but also when metabolism drops. Why? Because it's carbon dioxide that is the endogenous healthy vasodilatory factor. If your metabolism is not working well, you don't produce enough carbon dioxide, so the body activates the inducible nitric oxide synthase enzyme and starts synthesizing nitric oxide, right? Because that's in order to keep the blood vessels supple, at the cost of tremendous pro-inflammatory effect and further blocking of your oxidative phosphorylation. Because, like I said, if enough nitric oxide is produced, it will bind with the enzyme cytochrome C oxidase. And the only two things that I know that are capable of knocking it out of there are either methylene blue or red light. I think there's some suspicion that magnesium may be able to do the same, because it stimulates the excretion of nitric oxide from the cell. I think zinc and magnesium, actually, both of them are known to have that effect. But once it's bound there, so the only two things that are known to actually be able to break that bond are methylene blue, potentially other quinones such as vitamin K, coenzyme Q10, the tetracycline antibiotics, or sunlight at its major component, which is red light. So what happens then, basically, if you have a buildup of lactic acid? How do you handle it? Well, taking supplemental thyroid increases the rate of the metabolic rate, and also increases the production of carbon dioxide and shifts the balance back towards oxidation. Taking supplementary quinones can play the role of an emergency terminal electron acceptor, which is another way of saying this buildup of electrons, this buildup of NADH, can be handled by giving that electron to something else that is capable of accepting it, which in chemistry and biochemistry is known as an oxidizing agent. And there are a number of different ones, but the most well-known ones, the most famous ones, are quinones, specifically methylene blue, because the electron affinity of methylene blue is fairly high. It's one of the highest of any other substance currently in clinical use. It's about 5.4 electron volts. And as a comparison, the electron affinity of a quinone like vitamin K, or a benzoquinone like 1,4-benzoquinone, 1,2-benzoquinone that Dr. William Koch used in the early 20th century for cancer treatment, the electron affinity for those quinones is about 2.4 to 2.8. So, and because it's a logarithmic scale, methylene blue is several fold more potent It accepts electrons more readily than these other quinones. A number of different studies have demonstrated that supplementing with methylene blue alleviates a number of these metabolic blockades at specific steps, such as taking methylene blue reactivates or speeds up the oxidation of lactate and prevents the blockade of pyruvate dehydrogenase by this excessive shift towards reduction. In addition, if there is any block in enzymes in the electron transport chain complexes 1 through 4, methylene blue is capable of basically of circumventing the dysfunction of electron transport chain complexes 1 through 3, right? And then for electron transport chain number 4 complex, which is cytochrome C oxidase, methylene blue is potentially capable of getting nitric oxide off of that bond with the enzyme, so essentially it restores the function of electron transport chain complex 4 as well. And there's the number of different studies with other individual quinones for specific blockades and specific metabolic steps. But I think so far the most convincing evidence is for methylene blue, and it's enjoyed clinical use for a number of different conditions, including lactic acidosis, and even some conditions with which the doctors thought that they're caused by like a genetic inborn error in one of the enzymes, one of the genes that codes for one of these enzymes, like pyruvate dehydrogenase or succinic dehydrogenase, or the ubiquinone reductase enzyme in the electron transport chain complex number 2. So it just demonstrates that if you eat food, you will have a buildup of electrons. If these electrons have nowhere to go, the very first thing that will probably happen is lactic acid will increase, which not only has bad direct metabolic effects because lactic acid is a potent inducer of tumors, as per that study that I mentioned before the show, and I've already posted on my blog. But also because lactic acid, while it's high, you're in a state of virtual hypoxia, and all hell breaks loose when you're not using oxygen properly. I mean, just the very presence of hypoxia is sufficient to start the cancer metabolism. And if sufficient number of cells in an organ establish a quorum, in other words, they're in a compromised state and say, oh, no oxygen, we revert back to glycolysis, that's how you get the well-defined localized tumors. Furthermore, if you already have an established tumor, increased lactic acid is actually a sign. It enables the tumor to grow because it's a potent stimulator of vascular endothelial growth factor, which allows more blood vessels to form and feed the tumor and allow it to grow. And it also has been shown that lactic acid is actually the seed that keeps not the seed, but the factor that keeps the tumor stem cells alive and allows them to leave the primary tumor site, travel around, and form metastasis in remote tissues of the body. So really, lactic acid is not a benign thing, no matter what the keto community says. It's treated as a medical emergency by every emergency department around the world. You go in there and you're panting and you feel like you can't breathe properly. One of the first things that we do is do a blood test for lactic acid and or bicarbonate. And because these are inversely correlated, if your bicarbonate level is low, they'll immediately assume that your lactic acid level is high. And then being in a reduced state, basically it prevents, due to the Randall cycle, if the NAD to the NADH ratio is low, and if you cannot metabolize glucose, the only other thing you can metabolize is fat. And whether you believe in fat burning or not, it is hard to dispute the fact that every chronic disease that we currently know has a component of dysregulated fat metabolism. They call it dysregulated. What they really mean by this is that there seems to be a preference of tissues for fat, which cannot be explained by anything genetic, right? It's just with advancing age and in certain chronic conditions, cells of the sick person seem to prefer, quote unquote, to burn fat instead of the glucose. And if these people are given glucose, it just elevates their blood glucose levels, but it doesn't seem to get metabolized. It just elevates the lactic acid. Well, it seems that it's the redox balance, is that ratio of NAD to the NADH that really determines how well glucose is metabolized and whether your body prefers to use glucose and or fat. Another piece of evidence that has become almost indisputable at this point is that with advancing age, it has been shown that cells of old people have about the same capacity to metabolize fat as a person in their 20s, but the capacity to metabolize glucose tremendously decreases. And so far, no explanation in terms of damage to the cell's apparatus has been found to explain that. So the only thing that remains is an indirect cause, such as the redox balance. So shift the redox balance towards oxidation, and chances are that many of these intractable, incurable diseases that the doctors tell us that only genetic editing and turning us into mutants will be capable of solving, many of these seem to go away rather miraculously.
So to piggyback on what you had said earlier about like the electrons have nowhere to go, this is a quote from The Living State by Albert St. Georgi. And he says, this leads us to believe the first rule of electrobiology. The living state is the electronically desaturated state of molecules, and the degree of development and differentiation is a function of the degree of electronic desaturation. And so I think that desaturation means that there are few free electrons within the cell.
Exactly.
Is that correct? Okay.
And yes, then, exactly. So it's, yeah.
Go ahead.
So I forgot to mention another emergency mechanism the body has to deal with, and I posted, I think I sent you that link, is that synthesizing fat. So actually there was a study published that showed that actually like basically the accumulation of fat, aside from other reasons such as high cortisol, I mean, they're all correlated, but the primary driver behind this process is that these extra electrons have to go somewhere. And once they enter the Krebs cycle, if something else is malfunctioning, such as the electron transport chain, so the Krebs cycle can also have a buildup of electrons, right? So if there's a buildup of electrons in the Krebs cycle, the only other thing that can get them out of there is fatty acid synthase. That enzyme gets activated when there is a buildup of citric acid, which is one of the intermediaries inside the Krebs cycle. So if there's extra electrons, they cannot go through the electron transport chain and meet with oxygen, then the only other thing they can do inside the Krebs cycle is get converted to fat by the enzyme fatty acid synthase, which happens to be, non-coincidentally, upregulated tremendously in every single cancer type known to medicine so far. To the point that, even though your doctor is not going to tell you this, but you can Google it and verify this yourselves, there are multiple clinical trials right now with fatty acid synthase inhibitors as treatments, as hopefully cures for some of the worst cancers that we know, like pancreatic cancer, melanoma, neuroglioblastoma, a number of these cancers that have no known treatments. Well, maybe melanoma is kind of changing lately because they're starting to do immune therapy, but cancers that were considered that essentially untouchable, something as simple as inhibiting the ability of the body to synthesize fat, turns out to be tremendously therapeutic.
I honestly, we could keep going because you're on a roll and I love it. I think we do have to get to super chats because I'm at 25%. And if we get through them, let's go back to this topic and finish it out.
All right.
Okay, where the hell are super chats? Okay, here we go. Okay, I can barely see my monitor, but let's try to read these. Sandy says, Sandy is a great human, by the way, but Sandy says, helping a loved one on 30 milligrams methadone, 2 weeks on GABA, gotta turn up my brightness here, phenylalanine, theanine, T4, T3, Cipro, calcium, magnesium glycinate, metergoline, lizuride, 5-ADHP. Is this just damage central because of methadone? And 16 milligrams of methylene blue helps bipolar, but still some mania. So she's helping a loved one using 30 milligrams of methadone, and then she has him on a suite of like supplements. And is that enough to combat methadone in your point of view?
So hold on, the methadone is given to help them, or this person is quote unquote addicted to methadone and is trying to wean them off of it?
I think the latter. So Sandy is helping the loved one on 30 milligrams of methadone, I think.
Yeah.
Yeah.
So there have been a number of studies recently with humans showing that all of these quote unquote addiction problems stem from elevated cortisol. There have been many animal trials, but I think 2 human trials right now going on. One with pregnenolone, and the other one with the cortisol blocker RU486, also known as the abortion pill. Many people don't know, but RU486 was actually designed and developed as a cortisol blocker, and they only subsequently found that also blocks the progesterone receptor as well. So this is by design a cortisol antagonist. And the little data that we have from human trials shows that blocking the cortisol receptor or reducing the synthesis of cortisol removes the urge to abuse opioids and or alcohol. So all of these, the reason people abuse these drugs or alcohol is simply because they lower, like when you take these drugs, they lower actually, at least for a little bit, they lower cortisol and they give you a sense of calm. But then because they also downregulate the cortisol receptor, when you stop in the withdrawal period, you actually end up producing even more cortisol, right? This drives even further increasing the dosage or doing it more often. It's a vicious circle. But if you can control cortisol, then usually the urge to use opioids almost disappears. And then you have to go through the withdrawal period, and most of the withdrawal has been shown to be due to elevated serotonin. But there is another drug which has had a tremendous success in human trials of weaning people off of opioids, and that drug is called clonidine. It's an anti-adrenaline drug. Ray mentioned it in one of his articles. He called it the anti-stress drug clonidine. But it's got a number of different other properties. It also lowers cortisol synthesis. It lowers adrenaline levels. And there is some indication that it also lowers prolactin and serotonin. And at this point, to my knowledge, is used in many addiction clinics, even in the United States, to help with the withdrawal period. And something like 100 micrograms daily is typically enough to keep a person, to basically carry them through the withdrawal period. And after that, the maintenance for me would be keeping cortisol at bay. Thyroid should be addressed, right? Maybe cyproheptadine, and maybe a little bit of pregnenolone or progesterone. It doesn't have to be all of these, like a number of different chemicals. Usually addressing cortisol and serotonin and adrenaline is sufficient. So that's what I will do. No more than 2-3 things. Otherwise, they start interacting, and it's hard to know exactly what's producing benefit and what's not producing benefit. So yeah, pregnenolone / progesterone for cortisol, cyproheptadine for the serotonin and cortisol, right? And then clonidine is what I would reach for if the person starts either getting into withdrawal symptoms or starts to feel the urge to drink again. Naltrexone is a great one for reducing the urge of abusing the drug of choice, and also reducing the chance of relapse. And I think naltrexone is actually at this point used clinically. At this point, I think it's approved for managing alcohol addiction. And the alcohol addiction shares many features with opioid addiction, even though alcohol itself is not an opioid. Most people who are opioid addicts, they either transition into alcohol once their opioids are not available, or they're coming from alcohol addiction and switch to something stronger, namely the opioids. So if naltrexone can handle opioid addiction as maintenance therapy, I think it should be able to help the opioid one as well. It's just a matter of getting to the withdrawal period, which is pretty nasty. And I think clonidine is a great option for that.
And that was, Sandy, that was $20. So thank you so much, Sandy. Sincerely appreciate that. Pure Therapy for $4.99. Thank you so much, Pure Therapy. And they just have like a GIF, and it says, "How's it going?"
Not bad.
Thank you for that, Pure Therapy. Sincerely appreciate it. LEZ for $5. He says, Mom has, I don't know how to say this, Dupuytren contracture of her pinky. What can be done? I'll try topical Progest E. Anything else?
Yeah.
Thank you. Do you know what he's talking about?
So topical Progest E, I've also found like a number of people said that rubbing like an aspirin solution or a caffeine solution helps as well. DHEA tends to also help in such situations. So if you can mix, like if you can put some DHEA in the Progest E and dissolve it according to your recipe, right? I think like a mixture of progesterone and DHEA in about 3-to-1 ratio would probably work pretty well. And because progesterone is anesthetic, it also has the effect of like relieving the pain, which in many cases really is what makes this this condition like unbearable for its sufferer. It's not that dangerous by itself, but because it hurts so badly, that's what drives many people to other therapies, which are definitely not helpful. Some people even get prescribed opioids, and you don't want to go down that route because in the long run, actually, opioids were shown to increase the susceptibility to chronic pain due to their ability to activate the endotoxin receptor TLR4. So you're buying yourself minor pain relief, but setting yourself up for feeling a lot more pain later on, just because the opioids are such powerful endotoxin agonists. So yeah, caffeine, aspirin solution, both these should work. 1 to 2% solutions of either one of these should be sufficient to have an effect. Let's see, anything else? Pregnenolone solution may also work because it's been shown that when it's applied to the skin, like a decent amount of the pregnenolone gets converted to cortisol, but the cortisol stays in the skin. And for many people with joint issues, one of the first prescriptions they'll get is steroids, right? By steroids, I mean glucocorticoids. They'll either get like a prescription for cortisone injection or Medrol pills. It's still cortisone, or dexamethasone, which is a much more powerful synthetic glucocorticoid. None of these is really a good option, but topical pregnenolone has been shown to synthesize enough cortisol locally to make a huge difference for problematic joints.
Sweet. Thank you so much, LAZ. Great individual as well for $5. Thank you so much, Ellie. Drew F. Hey, Drew. $5. He says, Georgie, do you think a man can get away with using a 3-to-1 ratio of progesterone to DHA even if they have hypogonadism? Can I quickly comment on this?
Sure.
For what it's worth, just to totally anecdote, I have a totally different experience using a 3-to-1 progesterone to DHEA if I'm not taking thyroid versus when I am taking thyroid. So I think I wouldn't want to poison the water or anything because I'm not crazy. I don't think everybody's experience is my own, but and then maybe vitamin D also affects that as well. And so, but I'm curious to hear your thoughts, Georgie.
So in my experience, the 3-to-1 ratio is actually really anti-catabolic, and I want to use another word, starts with AN, but FDA prevents me from using it, basically when it comes to steroids. With a person, if the person has hypogonadism, like of course the symptoms, the ones that people worry the most about is accumulation of fat, loss of muscle, right? I mean the sagging skin, all of these things. In my experience, the 3-to-1 ratio is even better than the 1-to-1 ratio in terms of reversing or at least preventing like these from deteriorating. It's the libido issue that I don't think the 3-to-1 ratio would help much with. But adding just a little bit of pregnenolone to that ratio for some reason tends to happen tremendously with libido. So we already sell the 3-to-1 ratio, as many people know. The product Cortinone now by default comes in a 3-to-1 ratio. And I've heard from a number of different males, many of them over the age of 70, and they're saying that for many of them, actually, just the 3-to-1 ratio by itself was enough to restore libido. But in younger people, it seems to not help. It didn't hurt it, but it didn't seem to help. But if they added 5 to 10 milligrams pregnenolone with that intake of the cortisone, or the 3-to-1 ratio of progesterone to DHEA, the libido seemed to immediately come back up. I don't know why pregnenolone has that effect, but I've heard this from other people as well. The pregnenolone and DHEA combination seemed to work really well for libido and maintaining muscle tone, but it wasn't as strongly anti-catabolic as the progesterone and DHEA combination, which are more directly blocking cortisol than pregnenolone is. But pregnenolone seems to have a really powerful libido effect, and in my experience, combining the three of them, 3-to-1 ratio progesterone to DHEA, and adding a little bit of pregnenolone, 5 to 10 milligrams per dosage is enough to actually restore libido as well. So I think for most people with hypogonadism, this remedy would remove the need to actually go on a testosterone replacement therapy, unless you're in a situation where really you're so actually even for severely catabolic people, this seems to be at least as effective as TRT, testosterone replacement therapy, as testosterone without running the risk of as much of a risk of raising your estrogen. I actually can't think of a situation where testosterone would be preferable to this combination unless you're really a competitive bodybuilder and you want to build up huge Hulk-like muscles. Yes, the 3-to-1 ratio progesterone in the gym will not get you there. I mean, I'm sorry to say, but it is about as anti-catabolic as you can get. And in my experience, it beats testosterone in terms of keeping you in an anti-catabolic healthy state. It will not get you into the competition and win Mr. Olympia. But as far as an over-the-counter product, in my experience, it can replace testosterone for hypogonadism. The combination of progesterone, DHA, and pregnenolone, that is.
Sweet. Yeah. So, yeah, great stuff. Okay. Thank you so much, Drew. That was for $5. Thank you, Drew. Sincerely appreciate it. Drew has another question. Drew, I would love to talk about that and add on, but we are crunch time and my computer's going to turn off. So I just want to get through these as much as possible. I apologize. I'd like to expand on all of these things, but unfortunately just cannot. But yeah. Okay. Somo for $5. Thank you so much, Somo. They say, Georgi, have you read Stephanie Seneff's theory that nitric oxide synthase enzymes like ENOS can also produce, what is this? SO42 sulfate, not just NO nitric oxide. Thoughts?
I mean, I've seen it fleetingly. I mean, I've seen the references to it, but I haven't read it. I mean, what would be the context of, like, so in other words, the INOS would be like a helpful enzyme? I mean, sure, it could, right? But its primary purpose still is the production of nitric oxide. So that's my experience with it. And it's pretty well established even in mainstream medicine that once your carbon dioxide levels start to drop, I mean, INOS will get activated. And or if you're under a bacterial infection, nitric oxide, again, is starting to be produced at higher levels to battle the pathogens.
Sweet.
I'm sorry, I don't know more about it. I mean,
it's okay.
A little bit of context would have been helpful, as into like, do I know that the sulfide production will be beneficial, or like, do I think it's even possible, or like, what is the actual question?
They're limited on space of how long the question can be. But yeah, Somo, ask us again when my computer is not going to die. We could dive.
Or send me an email.
Exactly.
Send me an email and clarify.
Exactly. Thank you, Somo, for that $5. Thank you so much. Jeff for $10. Thank you so much, Jeff. He says, Georgi, if you had an quote autoimmune disease end quote illness, though it could be caused by a single autoantibody, were the first line treatment was IV immunoglobulin G IV.
Right.
Would you also try gut sterilization?
I would, but my go-to. So this is it's a good option for improving systemic health. But in my experience, one of the primary direct causes of the actual tissue deterioration, which triggers the production of the antibodies, is actually estrogen. So one of the first things I will do is try the Ray protocol with a quarter to a half teaspoon of the product Progesti, right? Which I think amounts to about 150 to maybe 300 milligrams of progesterone as a single dosage. And then he said you can go back to a maintenance dose after that, right? Just to get like this initial potent anti-estrogen effect, to get the estrogen out of the cell. And then if possible, I would actually combine this, depending on how severe the issue is. I would combine this with like an aromatase inhibitor, or keep the high progesterone dosage for a little bit longer, because progesterone is both an estrogen receptor antagonist and an aromatase inhibitor. It's just not very powerful as the latter. There are more potent options out there. I don't want to say a client, but there's a person I keep corresponding with, and their rheumatoid arthritis was so bad that basically the doctors said, look, we either have to replace your joints, which means like, pretty serious surgery, or we have to keep you on steroid injections every 2 days, every other day, basically. And you have to come in on the weekends because it's that bad. So that person, basically, they didn't try the antibiotics, but they're currently in a perfectly healthy condition, in the sense of that they're back to work, they don't have swelling, their RA is in remission, and their regimen currently is 100 milligrams of progesterone I don't know if they use progestin. They may be making their own. This person, it's a female. So basically, 100 milligrams progesterone in tocopherols and oil combined with 10 milligrams of the aromatase inhibitor exemestane. And that seems to be keeping their really brutal IRA that nothing else was able to control, to keep it in remission. And the doctor thinks because the progesterone is converting into cortisol, but their cortisol levels are actually, they're low. So it's really cannot be explained by that. So antihistamine drugs I would consider as well, because they won't lower estrogen, but they will block most of its effects. In fact, estrogen produces most of its negative effects in tissues through two mechanisms: the cholinergic pathway and in the histamine, and also the histamine pathway. You block both, you're largely negating the effects of estrogen, even though ideally you don't want it inside of the cell as well, because it is a reducing factor. It's an antioxidant by itself. It's like it will contribute to the drop in that redox ratio that we just discussed, right? A great chemical, a great drug that addresses both pathways is over the counter is Benadryl, also known as diphenhydramine. So I know people with autoimmune conditions who keep theirs in remission just by taking about 25 to 50 milligrams diphenhydramine daily. And another one, which is even better, but it's not over the counter, is cyproheptadine. It's also anti-serotonin, more powerful. Benadryl also has anti-serotonin effects, but it's not as powerful as cyproheptadine. So cyproheptadine is a powerful histamine blocker, a powerful anticholinergic, and a powerful serotonin antagonist. So that's what I would consider as well. And thyroid function needs to be addressed because, even though estrogen is the direct cause of the tissue disintegration, which is producing the antibodies, it's ultimately the thyroid function which maintains the integrity of the cell. So if these things work, the ones that I'm proposing, keep in mind that this is maintenance therapy mostly, right? I mean, some of these are pro-metabolic. The progesterone has a powerful pro-metabolic effect. Maybe thyroid function could recover just by keeping estrogen and inflammation at bay. But I think thyroid function needs to be assessed, and potentially some thyroid may need to be supplemented.
And Jeff, I'm almost certain I have a quote from Ray, a person asking about some autoimmunity thing, and him saying that he thought most autoimmunity was from dysbiosis in the intestine and high nitric oxide. And so I'm sure you've seen that quote. But in addition to all the things you had mentioned, all those things lower nitric oxide.
Yeah. And niacinamide is a great one because I posted a study on the forum about maybe even 6 years ago, which showed that raising the NAD to the NADH ratio may be a viable treatment for every single autoimmune condition out there. And keep in mind, niacinamide directly is a direct inhibitor of the synthesis of nitric oxide. It's a great way to lower nitric oxide levels in the body.
Sweet. Thank you so much, Jeff, for $10. Sincerely appreciate it. Roots K9 for $4.99. Thank you so much, Roots. They say, what form of vitamin D is best to supplement? Your preference, Georgi?
I personally like the D3 variety. Doctors seem to like the D2 variety. But for some reason, most of the clinically prescribed vitamin D2 seems to have some pretty bad excipients. I have not been able to see, because there's a database publicly accessible where you can look at all of the vitamin D products that are approved by the FDA and allowed to be prescribed by doctors, because that's what the doctor is going to go with first, right? They like these products because they get a cut of the profit, and also they like to abide by the FDA guidelines. Every single one of these had at least one bad excipient. The more benign ones had silica, which clearly you don't want, but most of the other ones had either talc and or titanium dioxide. And both of these at this point are known to be carcinogenic. We talked about the class action lawsuits against the companies in regards to talc and titanium dioxide, and you don't want to be ingesting these. There was a study I posted maybe about 2 months ago, which showed that a tiny dose of talc is sufficient to cause diabetes in laboratory animals. It amounted to about 100 milligrams of talc per day. And I guarantee you, even a single pill has more than that, like as an excipient. I like the D3 because you can get it in a fairly pure form. At this point, there's some mainstream commercial products that sell D3 as a gel cap. And some of them even offer certificate of analysis, and they seem to be a pretty decent product. I mean, but in order for you to raise your levels, and when they measure your levels, they actually measure D2, right? Um, and D3 does have one step that needs to be converted into D2, and it happens in the kidneys. But it's pretty reliable. So if your vitamin D levels are not rising, usually it comes down to insufficient dosage due to either the doctor telling you to take a lot less than you need to, and or carrying some extra weight, in which case, in my experience, the recommended dose needs to be doubled, and potentially both topical and oral route need to be used in order to raise the levels on the test that the doctors are using. And last but not least, the doctors, when they prescribe vitamin D, they tend to prescribe the once weekly dosage, which is higher, 50,000 to 75,000 IUs. And that, in some people, when taken as a single dose, it may cause issues with high blood calcium, which will freak your doctor out. So it's better, in my experience, to do the lower daily dosages. And for those dosages, vitamin D2, in my experience, is not available. It's only the D3.
Sweet. Yeah. The D3, I've been using the Carlson brand for a long time, and I think it seems to work well. Okay. John Estrada. Hey, John, for $2, he says, is it possible to reverse cavities?
Remember that study with aspirin they published just not even a year ago? They showed in the lab that it is possible. Now, usually tooth health is very closely correlated to overall bone health. And yet another study, which I posted about 3 years ago, showed that competitive athletes, the more competitive, the more accomplished they were, the worse their teeth health was. And it comes down to insufficient production of carbon dioxide and potentially increased gut permeability, because that gut bacteria is capable of translocating into other tissues, including your gums. So where it causes the periodontal disease, and from there it can also contribute to the cavities as well. So I know people who have reversed theirs, but they happen to be minor cavities. They weren't like to the point where the doctor says, I really need to like either pull out a nerve or like do like a reconstruction of the actual tooth. So if it's a minor cavity, I think putting like a few drops of vitamin K directly on top of it has a great effect, especially if it's combined with vitamin D. And because the cavities are caused by the bacteria, right? This recent study about vitamin D having the potent antibacterial effect, you may have the side effect, the desired side effect of also killing the bacteria. So you could be both helping to reconstruct the tooth and also killing the bacteria, which is causing the cavity. So I would try that, and also make sure your calcium intake is good and your carbon dioxide levels are where they need to be. If the blood test for carbon dioxide is in the middle, like the 50%, I think it's like 20 to 32 at this point. That's what the normal range is. If you're 25 or below, but still in the normal range, you cannot have, in my experience, you cannot have good dental health with carbon dioxide levels at that range. You need to be 28 or above for optimal dental health.
Sweet. Thank you so much, John Estrada. And thank you for that, Georgie. Another one from our buddy Drew F. for $5. Thank you, Drew. He says, do either of you think a person should pursue college if they are interested in these topics? I can't see my one. Opinions on the state of academia in general. I am completely removed from that, so I couldn't speak intelligently on the subject. But Georgie,
I don't think you should pursue it if you can get a free ride, and the school offers courses in biochemistry and biology. I think you can still extract a lot of value from these courses, because the knowledge is there. It's just polluted with a lot of other bad stuff. Mm-hmm. So you may have to perform some mental acrobatics and learn to tune out stuff that's really bad and dangerous for your knowledge. And also, I mean, you'll have to perform all the tests. Otherwise, of course, they're going to fail you in the courses. And that means writing some stuff that you will know to be wrong. Now, if you happen to find an open-minded professor, you may actually get a better grade by presenting a competing theory and challenging your professor to think for themselves. In my experience, most of them are authoritarians, so they will probably not like the alternative idea. So if you take those courses, because you can get if you can get them for free, you may have to write some things that you know are wrong. But depending on how interesting and how good the course is, it may be a price worth paying. But to answer your question, should you go to college for this? Absolutely not. I would only consider it if this is an easy option of getting access to some educational materials that normally otherwise you'll have to spend hours and days or even months like gathering around on the internet, and some of them are even behind a paywall. And being in school, being in college sometimes gets you access to these things just by virtue of being in the class.
Kyle Mamunis, who has his PhD, talked to Matt Blackburn, I think, about this exact subject. And so Drew should definitely listen to that. And by the way, you just had another interview with Matt, correct? Is that right?
Yeah.
Okay. And so you guys should check out, I think you can listen to his stuff on Spotify, and there's probably other ways, but the Mito Life podcast for Matt. Okay, 2 more, and we're at 9% battery. Okay, great. The Kirk one. I can't see my monitor. Kirk 333 for $5. Thank you so much, Kirk. Born with oily skin, specifically on the scalp and face, what can be done to reduce or eliminate the oil skin? Why would a baby be born with oily skin?
So I think a little bit of oily skin is normal for babies, but if an adult has oily skin, it's usually, in my experience, it's basically a sign of increased steroid production in the skin, which happens a compensating factor for like reduced thyroid/gonadal function. In my experience, the direct cause of oily skin is actually elevated estrogen. I have quite a few female clients, they're not patients, but females who email me, and they're saying that taking progesterone, some of them have PCOS, polycystic ovarian syndrome or disease, whatever you want to call it. And some of them take higher doses progesterone and their androgen levels dropped and their estrogen levels in prolactin also dropped. And in a few of them, actually, the androgens did not drop, but prolactin and estrogen did, and then happened to resolve the oily skin situation. So I think the direct cause is the estrogen irritating the adrenals and producing these precursors, which when they go to the skin get converted into basically into androgens, and androgens happen to increase sebum production and also the accumulation of fat in the cells on the surface of the skin. I don't know of the exact reason why a baby would have oily skin. In my experience, most baby skin tends to be a little bit more oily than like most of the adults that I know. It could be an issue with also like if during pregnancy the mother underwent stress. I know of a few couples whose babies were born either with excessively oily skin or hair, body hair, on like legs and arms. And in all cases, invariably, the mother underwent some kind of a stressful event. 2 of the mothers had surgeries during the pregnancy, which is a really stressful event for the baby and the mother. One other mom was in a car accident. And after that, basically, like her cortisol was through the roof for like 2 weeks. And she kept taking progesterone eventually to normalize it. And I think the last one basically that emailed me, she said basically that she underwent a really like messy divorce while she was pregnant. In all these cases, when the babies were born with oily skin and or body hair, there seemed to be maternal stress involved. So I would make sure that the baby is well fed and preferentially breastfed. If that's not possible, then at the very least, make sure that if you do the formula, just try to do powdered milk instead of all the other crappy stuff that's pre-made there and sold, because many of these formulas contain almost exclusively polyunsaturated fats, and they contain the gums, like the acacia gum, the locust bean gum, the emulsifying gums, and many of them actually contain even carrageenan. And recent studies came out that showed if the baby is exposed to these gut irritants very early on, it really sets their GI tract for trouble later. It increases the risk of inflammatory bowel disease or gut dysbiosis, a lifetime risk. So when this baby grows up, they'll have trouble with digestion just because of the presence of these gums. Just getting powdered milk, preparing with water, and adding maybe a little bit of vitamin D, a very tiny dosage, may be able to help with the oily skin.
Thank you so much, Kirk, for $5. Sincerely appreciate it. Michael, for $30 for Danny's external battery. They were saying I could fix my problem by using a USB-C external battery, which I will buy this week. Michael, thank you so much. I sincerely appreciate it. Guys, thank you so much for the super chats. Like I said last week, I am siphoning the super chats, and this stuff will help support this show. Oh no, we have another super chat. Okay, 6% battery. This is another one from Kirk. Back to oily skin. It seems to be a lot more after eating any oily or high bread meal. Can an aromatase inhibitor be used for lowering estrogen? Anything else? Thanks, guys.
Yeah, you can. I mean, my personal favorite one of the pharmacological ones are the steroidal ones, like exemestane, because all the ones that doctors currently prescribe and love, like letrozole and estrozole, bodybuilders tend to use them more often. They were shown to inhibit the synthesis of progesterone in the body, and also potentially DHEA. So all the zoles seem to be suboptimal. But the steroidal ones, especially exemestane, and at a lower dose too, because it has such a high, such a long half-life. It was shown that as little as 5 milligrams of exemestane daily, which happens to be only 1/5 of the typically used clinical dose, is able to drop estrogen levels by more than 65%. And at that dosage, it shouldn't really cause any of the other potential suppressive effects on the steroid cycle, the steroidogenic pathways, because it's just not a high enough dosage to inhibit some of the enzymes. Exemestane is itself, the body gets converted to an androgenic steroid known as 6-methylene-boldenone. And that is, as many people know, if you take an exogenous androgen, it can suppress endogenous production of steroids. But the lower dose exemestane, in my experience, is pretty good at keeping powerfully low in estrogen without wreaking havoc on your endogenous steroid balance.
Okay, Casper has a question, but to do it service, we really have to answer it next time. So, Casper, thank you. We will answer it next stream. Kirk, thank you for that $10 super chat. Guys, thank you so much. Let me just run through the all the things real fast here. I can't see anything on my screen. Not that. Okay, Georgi Dinkov, idealabsdc.com, boutique supplements from my buddy Georgi, who comes here so graciously. Nothing exchanges between us. This is beneficial for both of us, and we both enjoy doing it. And our deal is always to stop when it's not fun anymore. And that hasn't even come close to happening so far. So sincere appreciation for Georgi for joining me. You can follow Georgi. You can follow Georgi on Twitter at hateit. I do coaching, and that's how I support myself. And you can go to DannyRowdy.com/resources. You can follow me on Twitter, Instagram, the Danny Rowdy weblog on Instagram, and I try to put food things on there. And is it next week or the week after? I'm gonna have Emma Sarakis on, and we're gonna do a show, and so look forward to that. And then Georgi will be back towards the end of the month, I think, because our schedule is a little weird this month.
Yeah, hopefully by then I'll have a published study in a journal by yours truly, and I'm planning more studies. So stay tuned. Some more studies planned for this year, including the one on cellular immortality. So we may be able to prove the Hayflick limit wrong, and if we do, I don't know, maybe our houses will get raided by the FDA.
Amazing. We'll
see what happens.
Amazing. Thank you so much, chat. I keep an eye on that, and it's really great today. So thank you, everybody, for joining us, and making these streams as fun as they are, because the participation is really fun to behold. So thank you guys so much. Georgi, any parting words?
Just, stay healthy. Even though the world around you seems to be falling apart, I think sometimes it's just like a precursor to better things developing out of this chaos. If nothing else, we all know that the current situation cannot be maintained any longer. It's just a matter of riding through the rough waters for a few more years. But I think the house of cards is crumbling. So I'll do my best to contribute to that.
You heard it straight from the source. Thank you guys for everything. I'll see you soon with Emma, and then Georgi will be back on. Thank you guys so much. Have a great, safe weekend. I'll talk to you guys soon, and take care.
Peace.